So one of the first things that you will do when graphing a polynomial function of higher degree is identify its end behavior. The end behavior of a polynomial is a description of what happens as x becomes large in the positive or negative direction. For any polynomial, the end behavior is determined by the degree of the polynomial, whether it's even or odd, and the sign of the leading coefficient. All right, so that statement I just read is very, very important, okay? The end behavior of a polynomial is determined by the degree of the polynomial and the sign of the leading coefficient, okay? So what I'm going to do, if you look at the, at the rest of the page here, there are 4 big boxes, okay? There are 4 different possibilities for end behavior. So we're going to go through each possibility one by one. I'm going to draw it out and then we're going to write it down. We're going to, I'll state how you would write the end behavior of a polynomial. Okay? All right, so again, can't emphasize enough. End behavior is determined by the degree. You don't need to know the specific number. You just need to know whether the degree is even or odd, and then the sign of the leading coefficient. All right, so let's look at these first 2 boxes, okay? Both of these boxes are going to involve an even degree polynomial. The left box, you're going to have a positive leading coefficient, and then on the right side here, we're going to be dealing with a negative leading coefficient, okay? And then at the bottom, we'll talk about what happens if you have an odd degree polynomial, okay? So let's start with the top row here of boxes, the box on the left. So let's start looking at even degree positive leading coefficient, okay? This is how I want you to remember it, okay? So if you have a polynomial of even degree with a positive leading coefficient, compare it to the simplest polynomial of even degree with a positive leading coefficient that you can think of, okay? The simplest polynomial that has an even degree with a positive leading coefficient is f of x is equal to x squared, okay? That's familiar to us. It's a parabola, okay? So I'm going to draw out f of x is equal to x squared. Okay, so let me just do a little rough sketch here. Okay, so there's my x-axis, and then here's my y-axis. Okay, and we know that this parabola opens upward, and it also goes through the origin. Okay, so it looks like this. Okay, so like it was stated above, what end behavior is, it's telling you how the polynomial function is behaving at the endpoints. So what is happening as x gets bigger in the positive direction, and what happens as x gets big, well, it gets more and more negative. Okay, so if you're traveling out in the negative direction. Okay, all right. So let's think about this, okay? I've got 2 different ways you can write down the end behavior. You should know both. One is in just everyday English, and the other way you can write down end behavior is in a very mathematical way, okay? So let's start with the easier way first, okay? So this is the first bullet point here. To describe what's happening here, okay? It says blank left, blank right. Okay, so what's happening here, to fill this out, let's just kind of trace the curve. Okay, so it says what's happening to the left. Okay, well, to the left, we're rising. Okay, so we're going to write rises left, and then what is happening to the right here? Okay, well, to the right, if we travel along the right curve, we're also rising. Okay, so we're going to say rises left and it rises right. Okay, so basically, that's kind of the layman's terms of describing what's going on here, okay? The more mathematical definition is preferred. Also, if you plan on going to take Math 1325, which is business calculus, you're going to see this, okay? So I'd like for you to be introduced to it before you get there, okay? All right, so here's the mathematical statement. There are 2 parts to it, okay? So the first part says, as x approaches. Okay, so let me write that down. If you see that arrow, it means approaches. Okay, so the first thing that you would read as your x values approach negative infinity. Okay, so that means if your x values are going this way, look where my cursor is. If your x values are going in this direction, they're getting more and more negative. What is happening to the corresponding y values? Okay, that is what this statement means. As x approaches negative infinity, the y values approach what? Okay, so again, if you follow the yellow curve here, as your x values get more and more negative, so we're going to the left here, I'm drawing to the left on the x-axis. This is where you have negative x values. Their y values are getting bigger and bigger and bigger if you trace the parabola. Okay, so your y values, they're getting bigger and bigger and bigger in the positive direction. So they are going to approach positive infinity. Okay, and then the second part of this statement is you have to declare what happens as your x values get more and more positive. So if they travel to positive infinity, okay, so if your x values approach infinity, okay, meaning your x values are getting bigger and bigger and bigger in the positive direction, so they're going this way if you follow where my cursor is, okay, what's happening to the corresponding y values? Well, the y values are getting bigger and bigger in the positive direction as well. So they also approach positive infinity. Okay, so that's how you would write down the end behavior of a polynomial with even degree that has a positive leading coefficient. It's going to rise left and rise right. You can state it more mathematically as your x values approach negative infinity, the corresponding y values approach positive infinity. And as your x values approach positive infinity, the y values also approach infinity. Okay? All right, so just to kind of clear this up before we do the next case, okay? So say you were given the polynomial function, I don't know, negative 72x to the 16th minus 64x to the 7th plus 99x squared plus 12. You can tell I made that up. Okay, so when you look at this, the first thing you're going to do is look at the degree. Okay, the highest power of x here is 16. Okay, and oops, I made a mistake. Let's make this 72. Okay, if you look at the leading coefficient, okay, it's positive. It's positive 72 because I changed it from negative 72. So if you have this crazy polynomial function, okay, without putting it in the calculator, you know since the degree is even and it's got a positive leading coefficient that it's going to act like x squared at the endpoints. Okay, it's going to rise to the left and rise to the right. All right, so let's go ahead and look at the next case. Okay, so the next case is what happens if you still have an even degree, but now you've got a negative leading coefficient. Okay, so again, just think of something that's familiar to you that has an even degree and it's got a negative leading coefficient, something really basic. So let's draw that out. Okay, and then anything that is any polynomial that's even degree with a negative leading coefficient is going to act like this guy. Okay, all right, so the most familiar thing to us, or most basic thing I should say, is going to be the polynomial function. Even degree means x squared. Put a negative out front to make it a negative leading coefficient. Okay, so we know what x squared looks like. I just drew it. Okay, it's that basic parabola. Remember, if you stick a negative sign out front, that is going to reflect the graph about the x-axis. Okay, that's a transformation rule that we learned. Okay, so the graph of negative x squared is going to look like this. Okay, all right, so what you can see here is what's going on for this particular situation. Okay, if we travel to the left, okay, we're falling. Okay, so this particular graph falls left, and then it also, if you trace the right side, it's also falling to the right. Okay, so this one falls left, falls right. Okay, so if we had to go through the process of explaining this in a more mathematical manner, I'm going to give you this template. Okay, so if I ask you to state end behavior in this manner, I will give you this statement. You just need to tell me whether the y values approach positive or negative infinity. Okay, all right, so let's see what's going on here. So first, we've got to look as our x values approach negative infinity. Okay, so meaning if you're looking at these x values, look at my cursor. If we're going this way along the x-axis, if we're traveling in this direction, the corresponding y values are traveling towards negative infinity, okay? Because you're getting negative y values, they're getting more and more negative, okay? So your y values are traveling towards negative infinity. And then within behavior, you have to look in both x directions, okay? So now if your x values approach positive infinity, so if your x values get more and more positive, what's happening to the corresponding y values? Well, they're getting more and more negative, okay? So they too are approaching negative infinity, okay? All right, so any polynomial that I give you that has even degree with a negative leading coefficient is going to fall to the left and fall to the right, okay? If I go back up to this made up polynomial up here, if I change the leading coefficient to negative 72, now we've got even degree and negative leading coefficient. So this polynomial, without even putting it in the calculator, you know the end behavior, okay? Both sides are going to drop, fall to the left, fall to the right, okay? All right, let's get into what happens if you have an odd degree, okay? So odd degree, we need to look at if you have an odd degree and a positive leading coefficient, and then if you have an odd degree and a negative leading coefficient, okay? Let's start with odd degree, positive leading coefficient, okay? Again, you want to think of something very basic that we already know from this class. That's odd degree, positive leading coefficient. Okay, so here we go. Easiest thing we can think of is x cubed. Okay, that's got an odd degree and it's got a positive leading coefficient. Okay, so I'm going to go ahead and sketch a graph. Okay, it doesn't have to be perfect, just a rough sketch here. Okay, so here's the x-axis, and then I'll draw in the y-axis. Okay, if you remember, this particular graph is the S, the long S. Okay, so it did something like this. Okay, so this is the graph of x cubed. Okay, all right, so let's talk about what happens as this particular graph, if your x values, go to the left here, or if you travel along the left portion of this curve. Okay, so what happens? Okay, well, it falls. Okay, so this guy is going to fall left. Okay, and then if you go to the right side and trace it, it's rising. Okay, so the way we state this in everyday language is that this curve falls left and it rises right. Okay, so now let's do the more mathy statement. Okay, again, we've got to do the left side and the right side. Okay, so first, as your x values approach negative infinity, so if you're looking at these particular x values, if you follow my cursor, okay, as your x values get more and more negative, what's happening to the corresponding y values? Okay, they are traveling towards negative infinity on the y-axis. Okay, the y values are getting more and more negative. Okay, so your y values are approaching negative infinity. But then if you look at your x values approaching positive infinity, so if your x values get more and more positive, so the x values are traveling this way, what's happening to their y values? They are going up, 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 up forever. Okay, so they are approaching, their y values are approaching positive infinity. Okay, so that's how you would describe the end behavior of an odd degree polynomial with a positive leading coefficient. It's going to fall to the left, rise to the right. All right, so if I gave you, again, another glorious polynomial I will make up here. So let's say we had 100x to the fifth minus 32x to the fourth plus 1. Okay, when you look at this polynomial, the highest power of x is 5, so it's odd degree. The leading coefficient is 100, so we've got odd degree, positive leading coefficient. So if you put this polynomial into the calculator and you looked at its graph, you're going to see that it's going to rise to the right and fall to the left. Okay, all right, last case here. Okay, odd degree, but now it's going to have a negative leading coefficient. Okay, again, you want to think of the most basic function that we know, that's odd degree, negative leading coefficient. Okay, that's going to be x cubed, but we need to put a negative in front to make it a negative leading coefficient. Okay, let's sketch the graph. All right, so here is my x-axis, and then I'll put in the y-axis. Okay, we know what x cubed looks like. We just graphed it out. remember putting that negative sign out front is going to reflect it about the x-axis. Okay, so if you come back to this graph over here, okay, that we just drew, think about what it would look like if you reflected it about the x-axis. Okay, the piece of the graph that's in the first quadrant is going to fold down and come into the fourth quadrant, and then the piece that's in the third quadrant is going to flip up and go into the second quadrant. And so your graph is going to look like this. Okay, so this is the graph of negative x cubed. Okay, again, any polynomial that is of odd degree with a negative leading coefficient is going to behave like this at the endpoints. Okay, so you can see that it rises left and it falls right. Okay, so it rises left, falls right. Okay, now for the more mathy definition, okay, just follow the statement. As your x values approach negative infinity, so that means your x values are getting more and more negative. Okay, so we're traveling in this direction. The corresponding y values are going up in the positive y direction. So your y values will approach positive infinity. And then you need to look in the other direction as your x values approach positive infinity. So if they travel this way, the corresponding y values are going down forever. So the y values are getting more and more negative. They are approaching negative infinity. Okay, so if instead we had the polynomial negative 100 x to the fifth minus 32 x to the fourth plus 1, okay, this guy has an odd degree, negative leading coefficient. This is what it's going to behave. This is how it's going to act at the endpoints. It will rise to the left and fall to the right. Okay, so again, any polynomial that I give you, you can determine its end behavior. All you have to do is identify the degree and the leading coefficient. Okay, and then it will fall into one of these four categories.